I want to introduce the idea of inverse in algebra. You find the inverse of a set of ordered pairs by exchanging x and y of each original point. In other words, the original domain becomes the range, and the original range becomes the domain of the inverse. Here are some examples. I have these 3 points to the left, and since the x's are 1, 4, and 3, this is a function. The rule is that each x may only be used once. To write the inverse set of points, I just change the places for each x and y. So the first point inverted would be 2, 1. I'll change the second point to -2, 4. And I'll change the third point to 2, 3. When I look at the inverse that I just wrote, this set of 3 points, 2 is used in 2 of the points for x. So this is not a function because x values, specifically 2, repeat. You can also analyze this second set of points and determine whether it's a function. Write the inverse by exchanging x and y for each point, and then determine whether the inverse is a function. Please pause the video and complete the right side of this example. So as you can see, I found that this original set of points is a function. Each x is used only one time. And when I wrote the inverse set, each x is still used only one time. So the inverse is a function in this case because each x is unique. When you graph inverse, here I have a graph already made. It's a discrete graph. There is a symmetry for each function and its inverse. A function and its inverse are symmetrical. They're reflections of one another. Across this line, y equals x. So we'll fill this in. And this axis of symmetry, which going forward we may call AOS, a funky S, is that y equals x. I can label the points that are already graphed. They are -3, -1, and -3, 2, and -1, 1. I can then invert each point and write a list of inverse points. Don't change the signs. just write the x's and y's in the opposite order. So I'll have -1, -3, and 2, -3, and 1, -1. These are just points, but it might be easier to see the symmetry if you connect them. The steps for how to graph an inverse include step 1, create an XY chart to create ordered pairs. 2, graph these ordered pairs and connect the points to draw a line or a curve. 3, flip the ordered pairs to create an inverse chart. 4, graph the inverse ordered pairs and connect to draw the line or the curve. Notice that the lines reflect across the line y equals x. That's the axis of symmetry. Also, notice that the domain and range also flip. The domain becomes the range of the inverse. The range becomes the domain of the inverse. With these two examples, I'll start with a graph that's already made, and I can choose points that would be easy to log. I have a place to write 5 points. I'll put the vertex in the middle. So from left to right, I have -3, -2, and -2, 0. I also have 0, 2, 2, 0, and 3, -2. I can use those points to find the chart for the inverse points. I just have X and Y trade places. Make sure that you keep the signs with the numbers. I'm just checking my points. Yes, okay. So now I'll graph the inverse points. -2, -3, 0, -2, 2, 0. That's on both graphs. 0, 2 is also on both graphs. And -2, 3. This parabola, that's the inverse, is sideways. And the inverse and the original are reflected across the line y equals x. I can also make a table from this second graph. I'll choose points that seem to cross on a grid mark. I have a place to write 5 points. So I'll write in -4, 0 and -2, 1. I can write 0, 2 and 2, 3 and 4, 4. When I write the inverse for this table, notice that the original is f of x, and the inverse has f of x, but there's this exponent with a -1. That's inverse notation. So that's worth noting. This is inverse notation. This explains how the two sets of points are related. The original is a function, f of x. The inverse is found by exchanging x and y from f of x. So this notation explains that how I got the information compared to the original graph. So I'll just trade places for these points. 0, -4, 1, -2, 2, 0, and 3, 2. And the last one is still 4, 4. I can graph these points and draw the inverse line. 4, 4 is on both lines. The original, I can label f of x. The inverse, I'll label inverse of f of x. And these are also symmetrical across the axis of symmetry, which is the line y equals x. It's also possible to graph an equation, make a table, and then use that table to draw the inverse graph. So I'll use this f of x equals 3x minus 1 first. I'll just substitute each x in to the original equation. When I use x is -2, I'll have 3 times -2 minus 1. So I'll have -6 minus 1. That's -7. If instead I substitute -1, I'd have 3 times -1, which is -3, minus 1. That's -4. When x is 0, I'll have 3 times 0 minus 1. That's -1. And if x is 1, I would find 3 times 1, which is 3, minus 1 is 2. When x is 2, I have 3 times 2, 6 minus 1, which is 5. So I can use this table to graph f of x. -2, -7, -1, -4, 0, -1, 1, 2, and 2, 5. So this is a line. It crosses the y-axis where y is -1, and the slope is 3. When I write the inverse of this table, I have the points -7, -2. Here. Also -4, -1. And -1, 0. I'll have 2, 1. And 5, 2. And I will draw in this line. Now I have a y-intercept at 1/2, 1/3, I think, and a slope of 1/3. Please use this equation, substitute for x using these values, and complete the table. Then you can graph your points and find the inverse table, and please also graph the inverse. Pause the video and complete this graph. Just checking in with you. Is this what you got for your table and your points? I went ahead and added some more points to the left so you can see the rest of the curve. Just on the graph, not on the table. And then I exchanged x and y and drew my inverse graph.